Hi, and welcome to the Intrepid's live virtual programming, Journey to Space. My name is Karen. I'm an educator at the Intrepid Sea, Air, and Space Museum located in New York City, and I'm going to be taking you through today's program. Now, just as a reminder, the museum's live programs are free, but if you'd like to support us in delivering this content, you can click on the link located in the chat or in the comments, depending on where you're tuning in from. Now, speaking of the chat, feel free to chime in and tell us where you're tuning in from. Have you ever been to the Intrepid before? And if you'd like to participate or ask any questions throughout the program. Now, again, my name is Kara, and I'm an educator at the Intrepid Sea, Air, and Space Museum, where our mission is to honor our heroes, educate the public, and inspire our youth. So let's get started. So, like I said, I am coming live from the Intrepid Museum located in New York City. If you were to take the train to Times Square, walk west, you can't miss us. We are a giant ship located on the Hudson River, right in between New York and New Jersey. Our museum is very unique because it's actually housed inside of a World War II aircraft carrier, the USS Intrepid. Now, just a couple of neat things about it. Like I said, if you're walking down the West Side Highway, you cannot miss us. We are enormous. The ship is about 913 feet long. If you were to take that ship, turn it on its side, it would actually be almost as tall as the Chrysler Building. If you were to take that top part of the ship all the way down to the lower deck, it would actually be about 8 stories tall. Now, Intrepid began its construction in 1943, right before the bombing of Pearl Harbor. And it was finished about 18 months later. The Intrepid served during World War II, the Vietnam, and the Cold War, but also did some work for NASA, which we're going to talk about in just a little bit. So now that we know a little bit about the history, and I kind of hinted at it earlier, what do you think the job of Intrepid was, of the USS Intrepid? You can kind of see it here, right? Now, at the time, it was very impractical, very difficult to get airplanes across the ocean from continent to continent. So we created vessels like this that could actually carry those aircrafts and kind of cut that distance a little bit. It's kind of known as a floating airport. So let me know in the chat if you know what type of job it was or the specific name the USS Intrepid is. Now, I see some of us saying that it's an aircraft carrier. You would be correct. Like I said, it's basically like a floating airport. It could carry these airplanes, but these airplanes could also launch and land on top, just like a floating airport. So Intrepid served from 1943 to 1974 before becoming a museum in 1982. So it's a given when we say that we are a sea museum, right? We're the Intrepid Sea, Air, and Space Museum. We're a sea museum because we're a giant ship that floated out in the ocean. We were carrying these airplanes, which brings us to why we're an air museum, because we have a large collection of airplanes on board. Not only were we a floating airport, but today we have over 24 airplanes in our collection. We have everything from World War II, like the Avenger you here see on the screen, to jet planes that were used during the Vietnam War when technology became a little bit better. We also have a submarine, the Growler. We have the A-12 and a Concorde. We also have a space shuttle, which I'll talk a little bit more about in a little bit. But I mentioned too that we are a space museum. Can anybody in the chat tell me why we're a space museum if you think we're a space museum? Shuttle has something to do with it. I'll give you that hint. But it actually has to do with this object right here. So let me know in the chat if you know what this is. Like I said, I kind of hinted at it. It has to do with outer space. Take a good look. Take in the shape. It's kind of shaped like a light bulb or an ice cream cone. You can see that it's got vents on it. Also has what looks like thrusters at the end or at the back end maybe. So I see some of us are saying that it's a space capsule, and you would be correct. This capsule would sit on top of a rocket, either the Atlas or the Redstone rocket. When it would get to a certain height, it would actually separate, and this capsule would go on and do its mission, whether it's just going up into space and coming back, maybe it's orbiting around the Earth, right? So back in the 1950s, the U.S. was involved in something called the space race with that involved the United States and the Soviet Union. Now, at the time, they were Russia, and basically everybody was trying to see who could get to the moon first. right? And what basically launched the space race was on October 4th of 1957, the Soviet Union launched Sputnik, which was the first man-made object and satellite to orbit the Earth. Now, this made the U.S. very nervous, and we started to do the same as well. Now, I mentioned earlier that the space race was trying to see who could get to the moon first. It's a pretty solid finish line, if you ask me. Right. And so the U.S., when trying to figure out how they were going to get to the moon, broke it up into 3 segments. We had Project Mercury, Project Gemini, and the Apollo missions. So just looking at Project Mercury first, we had these 7 astronauts, and we're going to look specifically at Scott Carpenter. Now, Scott Carpenter, this Aurora 7 capsule belonged to Scott Carpenter. They each had their own one, and it was there were 7 of them, so there was a 7 at the end of each name. Like I said, this is the Aurora Replica. So this is the actual one. It's just a replica at the museum. But basically, this capsule would sit on top of the Atlas rocket. It would go up and it would separate while Scott Carpenter went around and orbited around the Earth 3 times. Now, what's really kind of uneasy about these rockets is that when the Atlas rockets were first being made, they were used as weapons. So they weren't 100% safe for humans at the time, or not built to carry humans up because they were weapons. Now, if you're looking at this rocket, it's about 94 feet long. So it's not too long compared to the other rockets that we're going to look at later on, because it was only carrying up that 1 astronaut. But as we started to take more people up, more technology, we're going to get a little bit heavier and a little bit taller. So like I said, Scott Carpenter went up in 1962. He orbited the Earth 3 times and was up there for about 4 hours and 39 seconds. So roughly about 5 hours. Now he's the 2nd American to orbit the Earth, and he's the 4th American to go into outer space. Oops. Now coming back to Earth, kind of gave it away. Let me know in the chat if you know where a nice soft space to land would be. If you're coming back down from space, where could you land on Earth that could kind of cushion your fall? And I'll give you a hint. The Earth is covered in about 71% of it, so it's a little hard to miss. Let me know in the chat if you know of a soft place that you could land in. So I see some of us saying the ocean, right? The ocean's a really great place to land because there's so much of it, and it kind of cushions and fall a little bit. But I'm going to let you in on a little secret. This isn't Scott Carpenter's landing or splashdown, because while Scott Carpenter was coming in, he got a little bit distracted looking out the window. And to be honest, if I'm in a capsule coming down from space, I'm going to want to look out the window too, right? So he accidentally got distracted. He fired his thrusters a little bit too late, about 2 seconds too late, and he landed about 250 miles off course. So of course there was no one there to take pictures. So this is kind of what it would have looked like in his splashdown. So once found, a helicopter would go and pick him up. He landed about northeast of Puerto Rico. So a helicopter could come pick him up. And can anybody guess where that helicopter might take him in the middle of the ocean? It's a place very near and dear to my heart. You might have guessed the Intrepid, right? So the Intrepid acted as a recovery vessel for NASA during the space race. And that is part of why we are the Intrepid Sea, Air, and Space Museum. Awesome. So we're going to come to a quick question break if anybody has any questions. Why was the capsule named Aurora? So the astronauts were able to name their own capsules, and he basically decided that he wanted to name it after the open sky and dawn. He wanted to symbolize the dawn of a new age. It was a really big deal. This was the first time that the U.S. was sending astronauts into space so that we could eventually get to the moon. Awesome. Any more questions? How heavy is the Atlas rocket? So I did mention that it's about 94 feet tall. It's about 10 feet in diameter, and it weighs about 260,000 pounds. Now you might think, wow, that's a lot. But trust me, they get heavier and heavier and heavier. And so it weighs about 260,000 pounds, but that's just the rocket itself, including with the astronaut and the space capsule adds another 3,000 pounds on top of it as well. So it's very heavy. It's not the heaviest. It's going to go up from here. Awesome. So I did mention that that Scott Carpenter and his capsule were not the only astronauts that Intrepid helped pick up. We also had these two astronauts right here. Gus Grissom and John Young were part of the Gemini mission. So we had Mercury, Gemini, and Apollo that was going to get us to the moon. So Intrepid helped in recovering these two astronauts as well. And during the Gemini missions, we learned so much from the Mercury missions that we were able to go just a little bit further in our experiments. This was the first time that astronauts could leave their space capsules and do spacewalks, right? Which was basically tethering to the capsule and being able to be outside of it. They were actually able to stay out in space longer, right? During Gemini 7, the astronauts could actually go up for almost 2 weeks. I cannot imagine being next to somebody for 2 weeks. It's crazy. But they were also eating food in space, and food at the time was really gross. It was cubed, it was dehydrated, and then when it was ready to eat, they'd have to reintroduce water into it, kind of squish it up and make sure it was evenly distributed, and then they'd have to slurp it in. So it wasn't super appetizing. So the day of their launch in 1965, after riding their Titan II rocket up into space, Gus Grissom and John Young were orbiting around the Earth, and John Young decides that he's going to pull out a corned beef sandwich on rye from his spacesuit that he had smuggled up into outer space. So, of course, here on Earth, we know that if you take a bite of your sandwich, gravity is going to cause those crumbs to land on your lap. But if you're in outer space in microgravity, those crumbs are actually going to start to float up. And if you think about it, those crumbs can get into the ventilation system. They can get lodged in the buttons, but they can also harm the astronauts themselves. It can get into their eyes and their ears and really cause a lot of harm when you're trying to come back down to Earth, right? So, of course, when Gus Grissom and John Young came back down to Earth, they got in a little bit of trouble. They had to personally apologize to Congress and say, "I'm sorry for sneaking a sandwich into outer space." And NASA warned all future astronauts that nobody better pull a stunt like this ever again. So even though they got in a little bit of trouble, it's actually a reason we know that you can't take bread into outer space. You have to use tortillas. Now, the rocket used in this Gemini 3 mission is the Titan II rocket. It's about 109 feet tall. So it's a little bit taller than our Atlas rocket. And it weighs in at about 340,000 pounds of mass. So it's definitely heavier, it's a little bit taller, but it can actually hold 8,000 pounds in payload, whereas Atlas could only hold 3,000. So like I said, we're getting bigger, we're being able to hold more, but we're also getting heavier as well. So just like our Mercury mission with Scott Carpenter, these astronauts again deployed this parachute, created a little bit of drag to help them slowly fall back down to Earth, catch some of that wind, land in the ocean, called a splashdown, and a big ship, again, near and dear to my heart, nearby, could come and pick up these astronauts. If you take a look at this picture, you can see that there's this green dye coming out of the capsule, and that's so that the astronauts in the capsule can be easily seen. There's also that yellow kind of floaty around the capsule, and that's called a flotation collar. And that's because Gus Grissom was also an astronaut on the Mercury missions, and when he was coming back down in his Liberty Bell capsule, he landed in the ocean and his hatch accidentally popped off. Now that's only supposed to happen in the event of an emergency, and there was no emergency because everything had happened so well. But when he got back down, that hatch popped off and his capsule started to fill with water. He thankfully escaped and was able to be rescued, but his capsule ended up sinking to the bottom of the ocean, where it stayed for about 30 years until it was picked up. So learning things like that from the Mercury missions helped perfect the Gemini missions. And just like learning that your capsule can sink if it doesn't have something to hold it up, helped the Gemini missions to create better capsules. Awesome. So as you can see here, there's a crane that would pick up that capsule. And today, if you visit the Intrepid Museum, you can see what it would have looked like when the Intrepid was picking up these space capsules and retrieving them for NASA. So I'm going to pause here and see if we have any questions. How many Gemini astronauts were there? So there were 10 crewed missions with 2 astronauts in each one. And it was called the Gemini mission because named after the constellation of the brothers or the twins. There were 16 astronauts with 4 flying twice. What were some improvements between the Atlas rocket and the Titan II rocket? So there were a lot of improvements, right? Aside from being taller, heavier, could hold more, the fuel changed, and it was actually safer to take up the astronauts. Remember, I said earlier that the Atlas rockets were used as weapons, so they weren't originally made to carry men into outer space. So there's one story about how in 1959 the Mercury 7 had been selected. They went to the launch site. It was a big deal to see this rocket go off. 1 minute after launch, the rocket exploded. And everybody was very uncomfortable knowing that that rocket was supposed to take them into outer space. So the Titan II rockets were improved so that they could take those men into outer space, a little safer than the Atlas rockets did. They also came with systems in them that could give them more time in case an emergency was happening, an alert system that they could actually be alerted earlier in case of an emergency and get out a lot quicker. Awesome. So I did mention earlier that the space race finish line was the moon, right? And we know that we did that back on July 20th of 1969 with the Apollo 11 crew. Was the third part. We had our Mercury missions, our Project Gemini, and then our Apollo missions that eventually got us to the moon. And without Mercury and Gemini, all those experiments led up to a successful landing on the moon. Now, just looking at the crew here of Apollo 11, you have Neil Armstrong on the left, you have Buzz Aldrin on the right, and you have Michael Collins right in the middle. So most of us always remember that we have Neil Armstrong and Buzz Aldrin because, of course, they are famous for walking on the moon. But Michael Collins was just as important. He basically drove the getaway car. So as they were walking on the moon, he was orbiting around ready to pick them up. So 6 missions accomplished going to the moon, bringing back like 400 kilograms of lunar samples and doing all kinds of really cool experiments like learning about meteoroids and solar winds. So it was a really big deal that they were able to walk on the moon almost 10 years after Sputnik had been launched. So the astronauts on Apollo 11 rode up on the Saturn V rocket that you can see there on the right. Today, it is the tallest, the heaviest, and the most powerful rocket that has ever been brought to operational status. So it's a really big deal. If you're looking at a comparison of the past 3 rockets that we've looked at, you can see that they've gotten bigger, taller, and they've gotten heavier. Just between the Atlas rocket and the Saturn V, you can just see the weight, right? Because we're going further. Going further requires more fuel. We are also bringing up more astronauts. More weight adds more fuel. You can kind of see what's going on there. So today at Intrepid, we have a very cool space shuttle called Space Shuttle Enterprise. After the Apollo missions, NASA decided that they wanted to focus on low Earth orbit, so pretty much staying closer to Earth, which means we needed to take up bigger things like more people, parts of the International Space Station, and the Hubble Space Telescope. Now, I hope this doesn't ruin your day, but Space Shuttle Enterprise at the Intrepid Museum never actually went into outer space. The highest it went was about 26,000 feet and traveled at a top speed of 470 miles per hour on the back of a 747 jet. So not very high and not very fast. But what was really cool about it was when it got to that certain height, it could actually separate and test out those wings to see if it could land on a runway, just like an airplane. Landing these space shuttles in the ocean like a capsule would have been extremely difficult to retrieve, so NASA had to think about how would it be easier to land this space shuttle. But you're probably wondering, how did we get from something like this to shuttles like this, ones that were able to go 350 miles off the surface of the Earth traveling at speeds 17,500 miles per hour when Enterprise just rode on the back of a 747 jet. Well, it takes a lot of rocket fuel and a little bit of physics. So we're going to take a look at those physics. And some of us might have heard of Sir Isaac Newton. So let me know in the chat if you remember or you're learning about his 3 laws of motion. He's famous for being the grandfather of modern day physics. He is the destroyer of GPAs. Am I right? So let me know in the chat if you remember any of his 3 laws of motion. So first law of motion, inertia, right? Which basically states that an object in motion or an object at rest will remain in motion or at rest until acted upon by an outside force. So if we think about the space shuttles, once that space shuttle gets up into outer space, it's going 17,500 miles per hour, which means that that space shuttle is going to keep going that speed until an outside force acts upon it, because there's no air resistance or anything slowing that shuttle down. But if that shuttle is here on Earth on the launch pad, it's going to need force to get off, or it's just going to sit there. An object at rest will remain in rest until acted upon by an outside force. So we need a force to actually get that shuttle off of the launch pad. Now next we have force is equal to mass times acceleration, Newton's second law. Simply put, we need to move stuff. In the case of the shuttle, that stuff is our rocket fuel. To get it moving, we need to ignite it. Newton's third law says that for every action, there is an equal but opposite reaction. So basically, if there's a force in one direction, you're going to have a force in the opposite direction as well, right? Now, it's important to realize that and to remember that the flow of exhaust is not what's pushing up the space shuttles. It's actually the force of the fuels mixing and hitting the top of the space shuttle that's causing our space shuttle to actually get off of the launch pad. So just to kind of think of the amount of mass and this equipment that we're forcing into outer space and writing an explosion, I want us to take a look at a shuttle stack here. Now the shuttle stack, if you can see, it consists of the space shuttle orbiter, right? That's that white thing with the wings. It's got its 2 solid rocket boosters, which are those white pieces on either end. It also has the external fuel tank, which is that big orange hot dog looking thing right in the middle of those 2 solid rocket boosters. So I mentioned a little bit about how in Newton's second law, force is equal to mass times acceleration. We're going to take a really good look at the mass here. So if you're looking at the space shuttle orbiter, just empty, and here we're looking at STS-135, so Space Shuttle Atlantis, on the left picture here. The orbiter by itself, completely empty, weighs in at about 150,000 pounds. By itself, empty, nothing in it. The solid rocket boosters, each one with its solid rocket fuel, weighs in at about 1.3 million pounds each with that fuel. Looking at that external fuel tank, that orange piece there in the middle weighs in at about 1.6 million pounds. But like I said, that was empty. We still need our astronauts. We still need our supplies, our equipment, and all of the science that's going up with them as well, which usually weighs in roughly about 12,000 pounds. So this thing is heavy. It's also very massive. If you take a look around the picture, you can see those little cars at the bottom just look so tiny. That one's a bus, looks so tiny compared to the shuttle stack. So it is a massive machine that is basically riding an explosion all the way up into space. So if we take a look here, we can see the comparison between the first rockets that we were looking at all the way to the STS. So it's gotten a little bit smaller, but we're able to pack so much more mass into a smaller grouping. You can also see that it's gotten very, very heavy. Like I said, we're trying to squeeze more mass into a smaller volume. So as these shuttles prepare to launch, with the right balance of our physics and our fuels, we can get these rockets all the way up into outer space. So let's take a look at what's actually going inside of our engines here. So before, I want us to kind of think of this like a candle and what's going on, right? You can't have a candle without its fuel. And in this case, that's going to represent the wax or the wick. In the rocket, it's the propellant, right? Now, with the fuel, you're going to add your oxidant, right? And you can't have a flame without oxygen. Once ignited, the fuel and the oxygen is going to bond together to release heat. If all goes well, you'll get fire. Ignition is that heat that you need to get things started. By putting energy in, you're going to begin this process. So looking at what happens on the launch pad up close, you're going to see those sparks flying out. Those sparks are actually going to burn off any excess vapors that you have going on here, because you have a lot of chemical reactions that are happening right before launch. There's also a pool of water that is released underneath the shuttle as well, called the sound suppression system. This is to catch any of that excess sound, because when these launch, they're releasing about 200 decibels of sound, and if that sound were to bounce off the ground and hit the shuttle stack, it could damage the actual shuttle and actually the crew inside. So they have to have a large volume of water underneath to kind of absorb some of that sound as well. So as we look at these space shuttle's main engines here, in blue, you can see the space shuttle's main engines. That's filled with liquid fuel. And those blue flames are created by burning liquid hydrogen and liquid oxygen from the main fuel tank. Now, these engines put out about 3,000 pounds of water per second when ignited. Now, the liquid hydrogen can generate about 375,000 pounds of thrust for liftoff, which is a lot. Now, the SRBs, or the solid rocket boosters, have a combination of powdered aluminum and ammonium perchlorate, which combined kind of feels like the consistency of a pencil eraser. So it's kind of almost rubbery. And that's located here in those red parts as well. Those SRBs can produce about 2.6 million pounds of thrust each. So these are very, very powerful. So now that we know what happens at launch, about 2 minutes after liftoff here, you're going to see something very interesting happen. The solid rocket boosters are going to actually be burned out. They're not going to have anything left in them, and you're not going to be carrying dead weight, because the less weight you have, the further you're going to be able to go with that thrust that you've created. So those solid rocket boosters are actually just going to fall back down to Earth. They're going to land in the ocean, and NASA's going to pick them up to be used. They're going to be recovered to be used in future space shuttle missions. So at this point, with our external fuel tank, we're about 24 miles off the surface of the Earth, and we're going about 3,000 miles per hour. And once our liquid fuel tank here has nothing in it, the same exact thing is going to happen to our external fuel tank. It's going to fall back down to the Earth, but this time it's not going to fall in the ocean. It's actually going to be burned up in the Earth's atmosphere and disintegrated. So we can't actually recover those and use them. So those have to actually be rebuilt every time that we have a space shuttle launch. So at this point, we're going very close to 17,500 miles per hour, but we need just one more push, one more boost that's going to get us to that speed. And that's where our OMS come in, or our orbital maneuvering systems. Now, these can be found at the far end of space shuttles. At the Intrepid Museum, you can't actually see these. They're covered by a giant tail cone. So the OMS is the propellant that the space shuttle needs to reach that extra 17,000 or extra miles to get to that 17,500 miles per hour. So we're going to take a look at what is actually going on inside this part of the engines. So the type of reaction that we're going to see in there is called a hypergolic reaction. Now you've got your fuel and you have your oxidant. Now, can anybody remember when we were talking about the candle and that equation and what we need in order to get fire? There's something missing from here. Let me know in the chat if you can remember what that piece is that we're missing to create our fire. Fuel and our oxidant. So our fuel here in this case is going to be monomethylhydrazine. It is a lot to say, and this is highly toxic stuff. It is not good. Our oxidant is our dinitrogen tetroxide, and that is also a very nasty chemical. It's a component of smog. So these chemicals are not nice to be around. You don't want to be inhaling them. They're pretty gross. But oops, I was mentioning about how we're missing something from our first equation. We have our fuel, we have our oxidant, but we're missing our ignition. And something very interesting happens when these two fuels are, or I'm sorry, the fuel and the oxidant are combined. You get this. Now, this may only seem scary if you've taken a chemistry class, but it actually looks like this. So when combined, you don't need an ignition to get that fire. They spontaneously combust when they come in contact with each other. So these chemicals, as highly toxic as they are, they're very much needed. In space, you want to kind of reduce the amount of fire that you have. You don't want to have to be lighting or igniting anything. So these two chemicals, once combined, can actually spontaneously combust. And you can also find this in the RCS, or the reaction control systems, as well. If you visit the Enterprise, you can see in those gray circles that this is where that would be housed. This is actually what helps create the roll for re-entry, right? When you come in a little bit upside down, it helps control the movement from side to side using Newton's third law. For every action, you have an equal but opposite reaction. So if you blast off on one side, you're going to turn your orbiter to the opposite side. So when the orbiter is ready to come back down to Earth, it's going to use those big, beautiful wings to kind of ride and glide, just like an airplane would. In outer space, those wings are pretty much useless because there's no air to manipulate. So you kind of don't need those wings at all. Till you enter the Earth's atmosphere, you can glide and use your landing gear to land on a runway just like an airplane would. Because like I said earlier, it would be really difficult if these landed in the ocean and were tried to be recovered just like the capsules were. And Enterprise proved that back in 1977 when it detached from that jet plane. It could actually glide and land on the runway just like an airplane as well. So a lot of principles go into what we're doing in the future. We're using a lot of what we have taken from our shuttles and our Gemini program and our Mercury program to take us even further into the future. So at this point, I'm going to stop and see if we have any questions. Why is the external fuel tank orange? So that was that big orange piece, I call it the hot dog, that's in between those solid rocket boosters. So inside we have liquid hydrogen and liquid oxygen, and those have to be kept at extreme temperatures. The hydrogen has to be at around -423 degrees, while the oxygen has to be at about -300. So that orange stuff is actually insulation. It creates kind of like a giant thermos for the external fuel tank. As it's going up, you don't want all of that liquid fuel on the inside to evaporate too quickly. It also keeps it from collecting any ice on the outside as well. You want to keep that whole shuttle stack as aerodynamic as possible. Now, the first couple of missions were, they were actually painted white so that the whole thing kind of looked like this big white spaceship going up into space. But NASA kind of realized that that paint was weighing down the space shuttle. All that paint used to paint the external fuel tank white was actually weighing it down an extra 600 pounds. So by eliminating all of that paint, it was actually able to be a little bit lighter. Good question. Any more? Why does the shuttle leave and enter the atmosphere belly up? So like I mentioned, using those reaction control systems in our OMS, we can actually kind of turn the space shuttle coming in. When the shuttle is leaving and at a certain point, it hits that max peak of the atmosphere pushing down on the shuttle. So by turning it, you have less of that pressure on the wings and on the tail, and it's less likely to damage, so that you have the belly facing upwards, so that you don't have as much damage or any damage with the atmosphere on the tip or on the tail as well. It helps reduce stress, essentially. Awesome. So you're probably wondering, why are we talking about space shuttles if we don't use them, right? You're like, Kara, I know that the space shuttles retired back in 2011 with Space Shuttle Atlantis. Why are we talking about these? Well, NASA's working on something very, very interesting. All right, so right now NASA is working on Project Artemis, and it's going to take the next man and the first woman back to the moon. So if we take a look at our comparison here, we've gotten not as big, but heavier, right? So if we look at a comparison here, oh, I don't have one, never mind. You can see that this is very massive, right? So it's about 322 feet long. So it's just a little bit under the Saturn V rocket that took the Apollo astronauts to the moon. NASA's trying to currently take humans farther than we've gone before. The space shuttles, the main engines, there's about 4. They're called the RS-25s, and they have the same liquid fuel that the shuttles do. It's also going to take the Orion capsules up, reaching speeds at about 24,500 miles per hour. So looking at these missions, we have Artemis 1. It's going to be the first unmanned project heading about 40,000 miles past the moon. Artemis 2 is going to send 4 astronauts to the moon, but Artemis 3 is actually going to take these astronauts and land them on the moon. The Gateway will also be going, which is going to be an outpost that's going to be circling around the moon. And we're going to have our lunar lander be created by SpaceX, and that's actually going to land on the moon itself, too. So as we wrap up, are there any more questions? Why are astronauts going back to the moon if humans have already been there? So as we're looking back to the very beginning, we wouldn't have been able to do any part of the Gemini missions without doing Mercury first. Just getting humans into outer space, what does it need to get up there? We couldn't do Apollo without doing Gemini, right? Because Gemini, we were spending a lot more time in space. We were eating different foods. And Apollo actually got us to the moon. The space shuttles helped us live in outer space for a lot longer, right? It helped take everybody to the ISS, which is currently going around the Earth. I like to call it like the hotel for astronauts. But we're currently working on going to Mars. So you can't just send astronauts to Mars without testing anything out and seeing if they can make it. You got to take these baby steps. And the moon is what's helping us get there by creating outposts, by living closer to the moon, basically in deep space is what's going to help figure out and learn what it takes to live in deep space and live on Mars. What do we need to take? What kind of resources are we going to need? Things like that. Awesome. Good question. So just as the early space missions were learning on how to get up into space and do those beginning projects, we've learned that we can do so much more than that. And just by learning a little bit about the past could take us into the future further than we've ever gone before. So I want to thank everybody for joining me today. Just a reminder, the museum has opened up a number of live stream programs. So if you like more, if you would like more content like these, you can like us and follow us to our live stream channels. Our next program is going to be this Thursday, May 6th from 3 p.m. It's called Snacking in Space, if you want to learn a little bit more about the evolution of what astronauts are eating. And just as a reminder, the museum is open to the public Thursday through Sundays, 10 a.m. to 5 p.m. So I definitely hope that you can come and check out some really cool things we talked about today. And if you enjoyed this program, we ask that you fill out a quick survey located in the chat or the comments. Cool. Now, again, my name is Kara, and we thank you for joining us today with the Intrepid Sea, Air, and Space Museum's Intrepid Adventures. Hope to see you next time, and may the 4th be with you.